forms protostars that can be likened to star eggs here and there in a nebula. When the gas and dust reach a high density, they begin to rotate, and a disk is formed around the protostar. In future, this will form planets like Jupiter or Earth, so it is called a protoplanetary disk. In due course, from the top and bottom of the enormous disk, a tremendous flow of gas and dust is disgorged from jets. This is called bipolar jetting. The jets erupting from the north and south poles of the protostar spread out several trillion kilometers into outer space. Gradually, the core of the protostar comes under high pressure from the incredibly intense heat, and a nuclear fission reaction that releases tremendous amounts of light and heat begins. The star that begins to undergo nuclear fission blows away the surrounding gas and begins to shine as a mature star. It is thought that stars are born in clusters from gas and dust in this way. But how are stars formed one by one inside these nebula of gas and dust? Because the detailed process is obscured by a thick cloud of gas and dust, it cannot be captured with an ordinary telescope. However, using new observation technology, human beings today are about to illuminate the process of star formation, which until now had been indiscernible.
This is the Space Radio Observatory on Mount Nobayama in Japan's Nagano Prefecture. 45 meters in diameter and weighing 700 metric tons, this millimeter wavelength telescope is the largest in the world. Here, radio waves from outer space are caught and developments impossible to see with light are observed. Normal telescopes catch and observe light emitted from celestial bodies. However, if there are gas clouds between the celestial body and Earth, light is obstructed. As a result, developments such as star formation taking place inside a nebula cannot be observed. However, radio waves have the property of being able to easily slip through clouds of gas. Therefore, by using radio waves, the form of celestial bodies hidden within the thick clouds of gas can be accurately captured. The radio observatory at Mount Nobayama is turned toward a star-spawning nebula. Then it repeatedly catches the faint radio waves that are emitted when a star is forming inside the cloud of gas and dust. This is an image of Taurus as seen through a regular telescope. The center of the picture is pitch black and looks as if there is nothing there. But when observed with a radio telescope, the gas and dust cloud becomes visible. The red areas indicate that a lot of gas has collected. This is a spot where a star is about to be formed. The radio telescope detects odd-shaped celestial bodies, the so-called star eggs, inside the dark clouds of gas and dust. This is the figure of large volumes of gas and dust which have come together into a disk and are rotating. This celestial body is called a Gigi Tau. This is a side view of the disk. The red color indicates that the gas and dust are moving away from Earth, and the blue color indicates that they are moving in its direction. This is L1551. The rotating disk and the flow of the jet spewing from the top and bottom are both beautifully captured. Red indicates the flow of the jet away from Earth, and conversely, blue indicates the flow spewing in the direction of Earth. Through the observations of the radio telescope, the detailed process of the formation of stars, previously hidden behind a thick veil, was brought to light.
Humanity only learned of the existence of jet flows a scant 28 years ago. And humankind still does not know the answer to why these tremendous jet flows occur in the process of star formation. The universe still abounds with mysterious developments in celestial bodies beyond the intelligence of human beings. Strange celestial bodies thought to be jet blowouts are one of these. These have been named after their discoverers and are called Herbig-Haro objects. More than 100 Herbig-Haro objects have been discovered. Next, let's delve into the true nature of these mysterious celestial bodies.
This is the Gum Nebula in Vela, which is visible in the southern hemisphere. On the end of it is a strange glittering celestial body that is long and thin. This is Herbig-Haro object HH47. The length of the object is 5 trillion kilometers. At more than 800 times the distance from the Sun to Pluto, its size is difficult to fathom. Moreover, it is moving at the tremendous speed of 1.6 million kilometers per hour. The reason why these celestial bodies exist was a riddle for a long time. Hubble Space Telescope is also taking detailed photographs of this odd celestial body. This is an image of HH47 taken by the Hubble Space Telescope. As a result of detailed analysis, we now know that protostars, or star eggs, are hidden in the vicinity of the arrow. It is believed that the jet flows erupting from a protostar collide with the surrounding gas, and the impact creates celestial objects like nebulae, which shine a yellow color. These are images of HH1 and HH2. They capture the jet flows erupting on each side of them. The brightly shining part of HH34 is 7 trillion kilometers from its star and is also an unusual shape. Through the observations of the Hubble Space Telescope and radio telescopes, the jet flows that occur during the process of star formation and the true nature of Herbig-Haro objects are gradually being explained. The jets are released from the north and south poles of the protostar. Moreover, the discharge is intermittent. As a result, the cloud produced by the collision of the jet with the gas is released at intervals. But why are there times when jets are released and when they are not? The reason is not yet understood.
In fact, this is a Hubble Space Telescope image, and we have more time coming up in the next year to take a look at this very same object. And what we will be doing is being able to look at this a few years later. We'll be able to see the motion of the object. So this is actually going to be a lot of fun. Within the next year, we should be able to blink between the two images and actually see the motion of the material outward. And we're going to be learning an awful lot about how this flow goes out and interacts with the surrounding environment from those types of images.
In observing other galaxies far removed from our own Milky Way, a researcher has been trying to explain the extremely puzzling mechanisms of star formation. Dr. Francois Schweitzer of the Carnegie Institution has been following the development of starbursts, the hundreds of millions of stars that are created at once from the huge collisions between galaxies.